Have you ever wondered what it would be like to build our entire world from the atom up? Well, that's exactly the promise of nanotechnology. Today, we're diving deep into this incredibly small frontier, a place where the basic rules of physics get turned on their head, unlocking possibilities that honestly were pure science fiction just a few years ago.
And this really gets to the heart of it. This isn't just about making things smaller. Not at all. It's about getting precise, deliberate control over individual atoms and molecules to construct completely new materials and machines. We're talking about engineering on the most fundamental scale imaginable.
So, what's the official definition we're working with here? Well, nanotechnology is all about manipulating matter that's between 1 and 100 nanometers in size. Now, that specific range, that is the absolute key. It's the point where the predictable classical physics of our everyday world just sort of fades away, and the bizarre, wonderful rules of quantum mechanics take center stage.
You know, it's almost impossible to wrap your head around just how small a nanometer really is. Let's try this analogy on the slide. Think of a marble in your hand. Now, picture the entire planet Earth. That's the difference in scale we're talking about between 1 meter and 1 nanometer. Your own hair is about 80,000 nanometers wide. A single strand of your DNA, just 2.5 nanometers. We are truly talking about a world that is almost beyond our ability to comprehend. Okay, so here's where it gets truly mind-bending. When you take everyday materials and you shrink them down to this nanoscale, they start playing by completely different set of rules. I mean, familiar substances that we think we know, like gold or carbon, suddenly develop these incredible new properties, superpowers they just don't have in our big, clunky world. So why? Why does this happen? What is the secret sauce of the nanoscale? Well, it's not magic, but you could be forgiven for thinking it is. It really all boils down to two fundamental principles that completely change the game when you're working with matter at this level. First up, surface area. Think about a sugar cube. Now imagine grinding that cube into a fine powder. You haven't changed the amount of sugar, but you've massively increased the surface area that's exposed to the world. At the nanoscale, this effect is taken to the absolute extreme, which makes these materials incredibly reactive. And second, you've got quantum effects. Down at this tiny scale, electrons can do things that seem impossible in our world, like tunneling right through a solid barrier. It's wild stuff, and it's what gives nanomaterials their truly unique optical and electrical abilities. This table really just lays it all out, doesn't it? In our world, gold is that familiar yellow metal, pretty unreactive. But at the nanoscale, it can suddenly appear red or even blue, and it becomes a powerful catalyst for chemical reactions. Materials that are normally weak can become unbelievably strong because the tiny flaws that weaken them in bulk form just don't exist at this scale. The properties aren't just a little different, they are fundamentally totally transformed. So if you want to build things in this strange new world, how do you even go about doing it? Well, engineers have come up with two main approaches, and you can think of them as the sculptor versus the builder. The top-down method is the one we're probably most familiar with. It's basically how we've been making computer chips for decades. You start with a big block of silicon, and you carve and etch away material to create tiny circuits. It's like a sculptor with a block of marble. But the bottom-up approach, now that is much more elegant and kind of futuristic. Instead of carving, you're building. You design molecules that are programmed to snap together all on their own into the exact structure you want. It's like having microscopic Lego bricks that build themselves.
And these techniques have given us a whole new class of supermaterials. Let's meet some of the superstars. We've got graphene, a sheet of carbon just one single atom thick, yet it's over 200 times stronger than steel. Roll that sheet up, then you get carbon nanotubes. And then there are quantum dots. These tiny crystals are like artificial atoms that glow in these brilliant, pure colors that change based only on how big they are. These are literally the building blocks of our future.
And listen, this isn't just stuff that's stuck in a lab somewhere. These materials are already out in the real world, and they're starting to reshape just about every industry you can possibly think of. In medicine, the potential is it's revolutionary. Imagine tiny particles that can seek out and destroy cancer cells while leaving healthy cells totally untouched, getting rid of the awful side effects of chemotherapy. Or picture microscopic robots swimming through your bloodstream, repairing damaged tissue, or monitoring your health from the inside. This isn't science fiction anymore, folks. This is the cutting edge of nanomedicine.
In fact, nanotechnology is already in your pocket and in your living room.
The reason your smartphone is so powerful, it's because of transistors that are now just a handful of nanometers wide. You know those super vibrant, pure colors on the latest QLED TVs? Yeah, that's thanks to quantum dots. And pretty soon, we could have flexible, foldable screens made from graphite. And the impact of nanotechnology stretches from right here on our planet all the way up to the stars. On Earth, we can use nanoparticles to filter and purify contaminated water with incredible efficiency. And up in space, materials made from carbon nanotubes are making spacecraft both lighter and stronger, which is an absolute game changer for exploration. As you can see from this table, nanotechnology isn't just one thing. It's a foundational platform that is sparking revolutions across dozens of industries. From more efficient agriculture that uses less chemicals to batteries that can charge in minutes instead of hours, these nano-innovations are making our world smarter, faster, and more sustainable.
Okay, this all sounds incredible, right? Almost utopian. But with a technology this powerful, a technology that operates at the very building blocks of life itself, we absolutely have to pause and ask some really serious questions.
Because with this kind of power comes an immense responsibility. This technology is not without its risks, and we really need to have a serious, open conversation about the challenges that lie ahead. So here's the paradox of nanotechnology. The very things that make it so powerful, its small size, its reactivity, also make it potentially dangerous. Because nanoparticles are so tiny, they can get into places in our bodies and in the environment where other materials can't, and we don't fully understand the long-term consequences of that yet. And the ethical questions, they're profound. Will this technology create a new nano divide between the rich and poor? What about privacy and security? These are the huge questions that we have to answer. So, navigating this future is going to require a delicate balance between pushing for groundbreaking innovation and establishing careful, proactive governance. And believe me, this future is coming way faster than you might think. We are seeing massive investment pouring in from all around the globe. This slide, for instance, shows India's nanotech market is projected to skyrocket, and that reflects a major global trend. This is no longer some niche scientific field. It's a major economic engine for the 21st century. So here's the bottom line. We have unlocked a new frontier with the power to solve some of humanity's biggest problems. But this incredible, mind-boggling potential comes with an equally profound responsibility to be thoughtful, to be ethical, and to be careful stewards of this technology. For the first time in human history, we can truly build our world atom by atom. The question is no longer if we can do it, but how we should. What kind of future are we going to choose to build? That's the real challenge that nanotechnology presents to every single one of us.